All right, this is 8th grade, activity 3.4. Today, our objective, students will solve real-life problems using equations, graphs, and intercepts. The standards covered are set 8F.4 and 8EE6. The page numbers are page 126 through 131 out of the hardcover book and pages 67 through 70 out of the practice journal. Today, we're going to be doing the activity out of the practice journal, so you'll need to open up your books to page 67. Here we have a scenario, and in your book, it also is giving us a word scenario as to what's happening in this equation. So it says, write a story that uses the graph at the right. Well, I'm just going to actually read that story to you. We're going to interpret, as we do this, we're going to interpret what our intercepts mean. We're going to make a table to represent the intercepts. I will make that, although your book already has it done. And then we're going to label those axes. Now, in the future questions that we go through and do, you will have to go through and actually do all of those, even though they're done in your book right now, for your future ones. So here we've got a picture, and we've got a line that's going from 175 on the y-intercept down to 7 on the x-intercept. So we've got a slope there, so we'll be working with some slope a little bit. So the scenario that they have given us is on page 67. It says, Tom works at an aquarium shop on Saturdays. One Saturday, Tom gets to work. He is asked to clean a 175-gallon reef tank. So I just noticed that I said 175, and I had already stated that the 175 was there. So this is our gallons of water. Okay. It says his job is to drain the tank. He puts a hose into the tank and starts a siphon. Tom wonders if the tank will finish draining before he leaves work. He measures the amount of water that is draining out to find 12.5 gallons drain out in 30 minutes. So he figures that that is a rate of 25 gallons per hour. To see when the tank will empty, Tom makes a table and shows a graph. So here's the graph. So I'm noticing that on the graph, we were working with gallons, which I already identified. And then we had these other numbers down here. Well, that other factor that we were working with was how long, so the amount of time. And when we went through and read through the story problem, it said that in 30 minutes, 12 and a half gallons would empty. So 30 minutes is more than what the numbers that we have here. So I'm guessing that these are hours, because he also stated that 25 gallons could be drained in 1 hour. And if I look at that 1 hour and I drop 25, it would put me at 150. So that's correct. So that's the number of hours that it's going to take there. So we went ahead and identified, we labeled our axes of the graph. We're not going to worry about drawing a picture. It says make a table. Now I know the table's already drawn for you in your book, but just so that we can identify how to actually draw that table, is we've got our x's and our y's. So x's, y's. And our x's, we went up to 7 here. 1, 2, 3, 4, 5, 6, and 7. And actually, I should have started at 0. So I'm going to make another box here, because 0 is going to tell us where we're starting at, like when he first came into work. At 0 hours, there were 175 gallons, and then it drops 25 gallons each hour. So if it drops 25, that would be 150. Drops another 25, that would be 125, 100. And I totally messed this up, so we're just going to erase those lines. So then at 4, it would be 75. At 5 hours, it would be 50, 25, and then 7 hours would put us down to that 0, or it's an empty tank. Okay, so the other thing that we're going to do is we're going to go ahead and write our equation. So our equation is going to be y equals, and then we need to do our rate. Well, how much did our water drop? Our water dropped 25 gallons per hour, so negative 25x, and we can see that this line is a negative line. And it originally started at how many gallons? A positive 175. So that's our equation for the line that we actually just went through and understood a little bit more about. Okay, so our whole objective in this activity is just to understand a little bit more about some real world scenarios as to why we're using that y-intercept equation. Okay, so here's, oops, That was our table. I already had drawn up. I didn't even have to draw it. Okay, so here's our next one. It says with a partner, so we're going to work this one together. Describe a real life problem that has the given rate and intercepts. Draw the line that represents the problem. So this is on your page 69. So if you flip to page 69, okay, so it looks like we're dropping 30 feet per second. So if we drop 30 feet per second, well, that's our slope. So negative 30x. Okay, and they went ahead and gave us our y and our x intercepts. So our y-intercept was 150. So there's our y line at 150, and our x-intercept was 5. And then you're going to use a straight edge. I'm just going to go ahead and draw a line. So there's our line. Okay, so there's our line to represent the problem. They also want us to write the equation. So we've got negative 30x. And then where did we start on our y-intercept? At positive 150. Okay, they would also like us to draw a table, and I know that there's not a table in your book, but I would like you to draw that table. So remember, our x's are always going to start out at 0, and we'll work our way up. So I don't know if I'll need all these boxes, which I won't. I can tell from there I only need to go to 5. 2, 3, 4, and 5, so I don't need these last two. Okay, and if it drops 30, originally it started at 150. If it drops 30 at 1, feet per second. So this was our feet, because we should label these. And these here, I don't have room, are our seconds. Okay, so then originally it was 150 feet. If it drops 30 feet per second, well, down 30 would be 120. Down another 30 would give us 90. Down another 30 would give us 60. Down another 30 is 30. And then down another 30 would put us at ground level or 0. Okay, so in here we went ahead and wrote our equation. We did our table. We labeled our axis point, or our axis labels. And we also drew in our graph. Okay, so I'm going to go ahead and have you work through letter B in your book, and when you're finished working through letter B, you can restart your computer and check to see that you have all of your information right. So you need to graph, go through and fill in your axis labels, write your equation, and fill in your table. Go ahead and pause your video now. Okay, so a real world situation for this would be maybe a bank account where you're taking $25 out every month and you originally had $200 in that bank account. Okay, so that's working with a little bit of those X, Y intercepts and creating or writing an equation from those situations. It's just that now they're giving us real life scenarios. So good luck with this.